Imagine this. You are drifting, weightless, no sound, no wind, no movement, except the slow, steady rhythm of your own heartbeat. All around you stretches a vast, endless darkness. Not the kind of darkness you know on Earth, but something deeper, quieter, almost absolute. A place where even light feels rare. And out here, the cold doesn't come from icy winds or frozen landscapes. It comes from something far simpler: absence. In space, cold is not something attacking you. It has no shape, no direction, no presence you can feel. Instead, it is what remains when almost nothing exists to hold on to energy. No air to trap heat, no oceans to store warmth, no currents to carry energy from one place to another. Only emptiness and energy slowly slipping away. If you placed a thermometer in that void, it wouldn't feel cold the way we do. It would simply measure radiation, what it absorbs and what it emits. And across most of the universe, that number settles at around 2.7 Kelvin. Just a few degrees above absolute zero, the lowest temperature physics allows. But here's the strange part. That number isn't random. It's an echo. A faint, ancient afterglow from the moment the universe was born. Light that has cooled and stretched over billions of years of expansion. In other words, the cold of space is the fading memory of a universe that was once unimaginably hot. And when you start to see it that way, cold is no longer just the absence of heat. It becomes a story about time. Here on Earth, we think of cold as winter, as wind against our skin, as falling snow, as the instinct to curl inward when temperatures drop. But all of those sensations share one thing: a medium. Air carries the chill to your body. Wind accelerates heat loss. Moisture sharpens the sensation. In space, none of that exists. If you reached your hand out into the void, you wouldn't instantly feel cold in the way you expect. Instead, your body would begin losing heat through radiation. A much slower process than standing in a freezing wind on Earth. It sounds counterintuitive, but in some cases, you could lose heat more slowly in space than during a harsh winter storm. Which reveals something subtle but profound. The cold of space is not an experience. It's a process. It doesn't touch you. It doesn't rush toward you. It simply takes your energy away, little by little. And because of that, in space, staying warm isn't always the biggest challenge. In fact, for both machines and humans, getting rid of excess heat can be far more difficult. So pause for a moment and think about this. On Earth, heat is always moving, flowing from warm places to cold ones. Air, water, land, they all help carry that energy away. But in space, with no medium to conduct or convect heat, energy can only escape as radiation. A slow, silent, invisible process. And that makes the universe a very strange place. A place where cold is not something active, but the default state of everything when nothing is left to hold on to energy. And as that idea settles in, another question begins to emerge.
If cold is the natural state of the universe, then the warmth we feel every day, where does it really come from?
If cold is the default state of the universe, then the warmth we feel each day is something remarkably rare, perhaps even fragile. Return for a moment to that silent expanse where you are still drifting, weightless, soundless. Far in the distance, a point of light begins to emerge. Not a lamp, not something artificial, but a star, a massive sphere burning in the darkness. It is places like these where heat is born, where the cold is pushed back, if only within a small pocket of space. Warmth in the universe does not spread everywhere. It exists only where energy is continuously created. And most of that energy comes from something happening deep inside stars, where light atoms fuse together, releasing immense amounts of energy as light and heat. Across millions, even billions of kilometers, that light can still reach a planet like Earth, carrying enough energy to warm its surface, to melt ice, to stir winds, to form oceans, and eventually to sustain life. But here's the quiet truth. That energy never stays forever. The moment light leaves a star, it begins a long journey through space. Nothing stops it, nothing holds it in place. And over time, as the universe expands, that energy is stretched, weakened, cooled, until it fades into the background, blending into the faint thermal glow we measure as 2.7 Kelvin. In other words, every source of heat eventually disappears. The universe, then, is like a vast, dark room with only a few scattered fireplaces still burning, while everything else remains immersed in quiet, persistent cold. Warmth regions exist, but they are the exception, not the rule. And because of this, when humanity began stepping beyond Earth, we encountered a challenge unlike anything we had ever faced. You might assume that in such a cold place, staying warm would be the greatest concern, but in reality, the opposite is often true. Imagine standing in direct sunlight in space. There is no atmosphere to soften the radiation, no air, no wind to carry heat away. The light strikes you directly, far more intensely than it ever could on Earth. Surfaces exposed to that light can heat up rapidly, reaching extreme temperatures. And yet, the moment you move into shadow, everything changes, instantly. No air to retain warmth, no medium to store energy. Heat begins to leave your body, radiating away into space. Not like a slow sunset on Earth, but as a sharp boundary between hot and cold, between light and darkness. This is why astronauts wear such incredibly complex suits. They are not just designed to keep warmth in, but to regulate temperature entirely, to prevent overheating in sunlight, and to slow the loss of heat in the shadows. Even for space stations, the challenge becomes more apparent. Inside those sealed structures, machines are constantly running, humans are living and working, and all of it produces heat. But outside, there is no air to carry that heat away, no wind to cool anything down. The heat becomes trapped, and if left unmanaged, it can build up to dangerous levels. So instead, space stations rely on large radiators extending outward into the void, slowly releasing excess energy as infrared radiation, quietly, continuously. It may sound like a paradox, but in the cold vacuum of space, the hardest problem is often not staying warm, but staying cool. And if you sit with that idea just a little longer, something deeper begins to emerge. Heat in the universe is not permanent. It is always being created somewhere, and at the same time, it is always fading away. Like a slow, steady breath of the cosmos,
inhaling through the burning hearts of stars and exhaling through the silent spreading of energy into the infinite dark. And then another question begins to form. What happens when one day those cosmic fires begin to go out?
Step away from the vastness of deep space, just for a moment, and let's pause somewhere more familiar, yet still profoundly alien. A surface with no air, no oceans, no clouds. A place where light and shadow exist like two separate worlds. This is the moon. From a distance, it looks sweet, still, almost timeless. But if you were to stand on its surface, you would quickly realize this is one of the most extreme environments humans have ever set foot on. Not because of storms, not because of violent winds, but because of something far more subtle, the absence of everything that normally balances temperature. When sunlight strikes the moon, there is no atmosphere to scatter the energy, no protective layer to soften the intensity of radiation. The light falls directly, unfiltered, uninterrupted, heating the surface to temperatures exceeding 100 degrees Celsius, hot enough to scorch anything exposed. But when the sun sets, everything changes. There is no atmosphere to trap heat, no oceans to absorb energy and release it slowly over time. The warmth built up during the day begins to vanish, radiating away into space, and before long, temperatures can plunge to hundreds of degrees below zero. This is not a gentle transition like a sunset on Earth. It's more like stepping through a doorway from a room filled with warmth into one with no heat at all. And in that contrast, we begin to understand something essential. On Earth, temperature is not determined by distance from the sun alone. It depends on something deeper, the ability of an environment to hold on to heat. Our atmosphere, our oceans, even the ground beneath our feet, they all act as thermal memory, absorbing energy in the light and releasing it slowly in the dark. That is why we rarely experience extreme temperature swings in such short periods of time. But in space, or on worlds without an atmosphere, everything is different. There, heat is never stored. It simply arrives, and then it leaves. And if you think about that just a little more carefully, you begin to realize something remarkable. The stability we experience on Earth is not guaranteed. It is the result of a delicate system, a quiet balance of many elements working together to keep conditions within a narrow, livable range. We take it for granted, the warmth of the day, the coolness of the night, never really considering that if even one component were missing, like the atmosphere, that entire experience would disappear. And it's not just the moon. Many places across our solar system exist in similar extremes. Worlds with little or no atmosphere endure violent temperature shifts, while others, wrapped in thick atmospheres, can retain heat far more effectively, sometimes too effectively, trapping energy to dangerous levels. But in every case, the same principle holds true. Heat never stays forever. It exists only when conditions allow it to be held. And this truth extends beyond planets, beyond moons, even to the stars themselves, the greatest sources of heat in the universe. Because no matter how eternal they may appear, every star is quietly consuming its own energy, little by little. The light we see today is part of that process, energy leaving the star, never to return. And if you allow your perspective to stretch far enough, across millions, billions of years, a larger picture begins to emerge. A universe where sources of heat slowly fade. A place where the balance between hot and cold can no longer be maintained. A cosmos where cold, the natural state, begins to spread, slowly, inevitably, irreversibly. And now, the question we touched on before comes into focus more clearly than ever. What happens when all of these sources of heat finally run out?
Now let's go a little further. Not through space, but through time. Not years, not centuries, but billions, trillions of years. a span so vast that everything familiar to us today slowly becomes distant, and then disappears. In that quiet expanse, the stars, once the blazing fires of the universe, begin to change. Not suddenly, but slowly, almost imperceptibly. They continue to shine, they continue to radiate heat, but deep within, their fuel is running out. Every star exists in a delicate balance. Gravity pulls inward, while energy from nuclear reactions pushes outward. As long as there is fuel, this balance holds, and a star can shine for millions, even billions of years. But nothing lasts forever. As the fuel begins to fade, the balance starts to shift. Some stars expand, growing larger, redder, cooler at the surface, yet more turbulent within. Others end in violent explosions, brief, brilliant moments where immense energy is released, before leaving behind a silent remnant. Eventually, what remains is no longer a powerful source of light. Only stellar cores, cooling slowly, dense, quiet objects emitting the faintest traces of leftover heat. And over time, even these final embers continue to lose energy, radiating into space until almost nothing is left to give. If you could stand in that distant future universe, the view would be unrecognizable. No more star-filled skies like the ones we know. No soft glow from spiral galaxies. Instead, a darkness that deepens over time, where light itself becomes rare. The temperature, already unimaginably low, continues to fall. Not because something new is making it colder, but because there are no longer enough sources of heat to sustain any meaningful difference. This is what scientists often call the heat death of the universe. It sounds dramatic, even unsettling, but it is not a sudden event. There is no moment when everything simply switches off. Instead, it is a process, stretched across unimaginable time where energy gradually spreads out evenly everywhere. In that state, there are no significant temperature differences, no flow of energy from one place to another. And without that flow, no processes can occur. Because at the most fundamental level, everything, life, motion, change, depends on differences in energy. When everything becomes uniform, the universe enters a stillness deeper than anything we can truly imagine. But perhaps the most meaningful part of this idea is not that distant future. It's how it changes the way we see the present. Because right now, as the universe slowly moves toward that state, we are living in something extraordinary. A moment in time where stars still burn, planets still hold warmth, and life is still possible. In other words, we exist within a rare pocket of warmth inside a universe that is, by nature, cold. And if you sit with that thought just a little longer, something shifts. Not a fear of a distant future, but a quiet awareness of the present moment. That the light you see each day is not guaranteed. That the warmth you feel does not exist everywhere. And that, within this vast and silent universe, these moments of warmth are incredibly rare. And perhaps it is precisely because of that rarity that they are so deeply valuable.
Now let's return, not to billions of years in the future, but to this moment, right here, where you are sitting, listening, quietly aware of the space around you. Maybe it's the gentle warmth of the room, the soft air brushing against your skin, a warm cup in your hands, or simply a steady, comfortable temperature you hardly ever notice. All of these things feel ordinary, almost invisible in the rhythm of everyday life. But when you place them against the vast backdrop of the universe, they become something extraordinary. Because for a place like this to exist, so many conditions have to come together perfectly. A star, stable enough to provide energy for billions of years. A planet positioned just right, not too close, not too far. An atmosphere thick enough to hold warmth, yet not so heavy that it traps too much. Oceans that absorb and redistribute energy, softening the contrast between day and night. And all of these elements must exist together, remain stable, and endure long enough for life to emerge. When you see it this way, warmth is no longer something ordinary. It becomes something delicate, like a small flame carefully protected within a vast cold expanse. A candle, burning quietly in the dark. And perhaps the most curious thing is, we tend to notice warmth only when it's gone. When winter becomes too cold, when the sun disappears behind heavy clouds, when comfort quietly slips away. But on a cosmic scale, cold is not the exception, it is the foundation. Warmth is the rare thing. And that realization offers a perspective that is both gentle and profound. That what you experience each day, the morning light, the balanced temperature, the simple comfort of resting, is the result of an incredibly delicate chain of conditions. Not every place in the universe has this. Not every moment in cosmic history allows it. But right now, it exists. Here, with you. Someday, far in the future, stars will fade. Heat will continue to disperse into the silent vastness. The universe will grow darker, colder, quieter. But that is a story for a time so distant it's almost beyond reach. Right now, there is still light. There is still warmth. There are still small, quiet moments you can feel, even in silence. And maybe, when you truly understand that none of this is guaranteed, you begin to appreciate it in a different way. It doesn't have to be something grand, just the awareness that in a vast, cold universe where most things are slowly cooling over time, you are here, in a place that is warm. And for this moment, that is enough. Let that thought stay with you for a little while longer, as everything around you grows quieter, slower, and gently drifts into sleep.